the solid E bounded by y squared plus z squared equals 9, z equals 0, and x equals 5 is shown in the following figure. Evaluate the integral z dv over the region E by integrating first with respect to z, then y, and then x. So with this problem, they give us the integration and the order in which they want us to do it. In most cases, we have to come up with our own choices for that. So just keep that in mind here. So the first thing we're going to do is look at z here. So we need to understand the bounds for z. Now, one thing to realize is it said z equals 0, so that means right at the xy plane here. So that xy plane, I'm not going to go below that. So that's my z equals 0 there. And then when I look at this equation here, x squared plus y squared plus z squared equals 9 here, what we're going to do is we're just going to try to find out where that bounds is at. So we're just going to take that equation. So y squared plus z squared equals 9. And then we're just going to solve this for z. So I'm going to move the y squared over. So that's going to be 9 minus y squared. And then we're going to square root both sides. And then in the process of square rooting, we get z equals plus or minus the square root of 9 minus y squared. Now what I want you to see here is let's just take away the negative for a minute. And let's just look at the positive. All I want to do is just map this. So let's say I plug in -3 for y. If I do that, that's going to give me a 9 here for the y squared, and 9 minus 9 is 0, and the square root of 0 is 0. So the point we found was this one right here. And then from there, let me plug in 0 for y now. So I plugged in -3, and I got z equals 0. And then I'm plugging in y equals 0. And when I plug in 0 here, 0 squared is 0, so I get the square root of 9. So then my z equals 3. And when I go to 0 here, and there's my 0 for my y there, I'm going to get 3 for my z. And that makes sense there. And then I'm just going to do one more, y equals 3. Oops. And then when I do the y equals 3 now, that's going to give me a 9 again, because I'm going to square it and I'm going to subtract it, and that's going to give me z equals 0. So I end up with this point here. So in that mapping, I don't need the negative. And if you didn't notice, this equation here, y squared plus z squared equals 9, is really a circle. Not really a circle, but a cylinder. So if I was to draw the rest of it in here, it would be this, and then it would run forward. And that's what I would end up with. But this is only taking the top half of that cylinder that's running along the x there. So that's why, so that makes sense then why I would only need the top half of the cylinder. And that's really what I'm looking at here when I have z equals the positive square root of 9 minus y squared. And that's why I don't need the bottom half there. So I just get rid of all that, and that's what we're dealing with. That's why when I seen that mapping there, it made sense why the mapping is the way it was. Okay, so anyway, so now we have our bounds for our z. So the lower bound is going to be 0, and the upper bound is going to be this square root of 9 minus y squared. So there it is. And we also have our z, and this z comes from just the integral we're integrating here. So that's our z, and then we have our dz now. Okay, now we need our dy, because it said y was our next variable to use. So dy. So when I look at dy here, dy simply runs from -3 to 3. And we did the mapping earlier, and that really gave our parameters for y as well. I know when I plug in -3, I get the square root of 9 minus 9, which is 0. So all of that was the bounds for that y as well. And then for our x then, and that's our last one, that dx, the dx is going to run from 0 to 5. And we know we were at the origin here. And that origin's going to run all the way up to x equals 5, it says, hey, we're chopping it there. And honestly, that's this plane here, x equals 5, and it's saying slice it right there. Now, another condition that should have been added that wasn't added to this problem was it should have said the first octant or x equals 0. Now, the reason why is because when you look at this problem, it would still extend this way because it's not bounded that way. So I think that's one of the problems with this problem. It should have had z equals 0 as well in that. Or, I'm sorry, x equals 0. Or in the first octant. Either one of those two would have satisfied the condition of just this little sliver that we see here. And I understood that by the picture, but if I was just looking at the equations, that wouldn't have been enough. So now let's get into this integral. So the integral from 0 to 5. The integral from -1 to 3. Oh, -3 to 3. See how that changed so quickly? It's a terrible looking 3 down there. And then this, when I integrate it, is going to be 1/2 z squared. And the bounds is going to be from 0 to the square root of 9 minus y squared. And then I have dy dx that I'm going to have to do next. Okay, so this is the integral from 0 to 5, the integral from -3 to 3. And then when I plug in this upper bound here, I'm going to get 1/2, and then I'm taking the square root of 9 minus y squared, and I'm squaring it, and then it's going to be minus, and when I plug in that lower bound, that's going to be a 1/2 0 squared, which that's just going to result in 0, so I'm not going to worry about it, and that's going to be dy dx. So now the next step then, that's going to be the integral from 0 to 5, the integral from -3 to 3. And then when I square this, those are going to cancel. So I'm going to get 1/2 9 minus y squared dy dx. Now from here, I'm going to integrate with the y now. So that's going to equal the integral from 0 to 5. And that's, I got the 1/2 still here. And that's going to be 9y minus 1/3 y cubed. And that's going to run from -3 to 3 dx. So now when I actually plug in the upper bound minus the lower bound, I'm not going to run through all of that in this video, so you can pause this if you want and work it out. I would recommend that because you must be convinced in yourself, but this is actually going to give me an 18 dx. And then when I do my last integral, this is going to be 18x from 0 to 5, and that's going to give me 90, and it's minus the 0 because when I plug in the lower bound, and that's just 0 there, so it doesn't add anything to it, so our answer is 90. So just remember, when doing these integrals, it's the bounds that are going to be the big issues for us. And like I said before, we really have to write first octant or x equals 0, that plane, in order to make this problem correct without the picture. So anyways, that's it. And remember one more thing here, finding those bounds for z. Make sure you do your mapping of the equations you come up with to make sure you have what you're supposed to have.